Before we can define what a group is, we must define two properties. A set is a collection of things. For example, the natural numbers 1, 2, 3, etc. These numbers within the set are known as elements. Now that we have defined our set of elements, we can perform operations on them. An operation combines elements of a set to produce a new element. Operations must be well defined. That is, if I were to give you two elements in an operation, you should be able to apply it. There is only one solution. A group is a set G combined with an operation such that the group contains an identity, contains an inverse, is associative, and is closed under the operation. The group contains an identity if we apply an operation to an element and the identity and we get back the same element. For numbers, it can be seen that for the addition operator the identity is 0 and for the multiplication operator the identity is 1. The group contains an inverse if for any element in the group there is another element such that when the operator is applied, the result is the identity. The inverse is unique for any element. The operation is associative if the order of which an operation is applied does not matter. Here we can see that A is applied to B, which is applied to C in two different ways to give the same result. Once any two elements are within a group, using operations will result in a new element within the group. This means that the group is closed under the operation.
This branch of maths first started developing in the mid-1700s with three main areas of growth. The first was Carl Friedrich Gauss expanding on Euler's work in 1807, which resulted in much of the theory around abelian groups, which he used to examine the order of elements. The second main area in which group theory was developed was headed by Joseph Louis Lagrange, who first studied permutations and developed the theory of algebraic equations. His work on trying to solve qubits and quartic equations algebraically is attributed with being the beginnings of permutation group theory. The third area to contribute to the rise of group theory was its systematic use in geometry, mainly in the form of symmetric groups, which were first developed by Felix Klein in 1872.
Mikhail Gromov revolutionized the subject of groups through his definition of the geometric group theory, defining groups as geometric objects. Geometric group theory uses geometric and topological methods to deduce information about groups associated with shapes. Let's consider the equilateral triangle. This shape can be rotated by the set S equals rotate 120 degrees, rotate 240 degrees, rotate 360 degrees, without altering its appearance. This shape has rotational symmetry. Further study of the equilateral triangle shows that it also has a mirror reflection symmetry. Mirror reflection symmetry is the idea of drawing a line through the shape and reflecting the shape through the line without changing its appearance. There are a group of three different mirror lines which the shape can be reflected without looking different. One way of identifying whether a group is a geometric object is through the Cayley graph. For example, the Cayley graph of this group is a cycle with a single generator, or physical interpretation of an operation, for example the rotation. By using the properties of group theory, we can apply inverses and associative properties to the variables to solve for the unknown x.